Alright class, here we are on number 2, and this one I'm going to go a little bit quicker with it, so you may need to pause between, maybe I'll pause 5 seconds between steps. And after we go through number 2, I'm going to turn the page and there will be 4 practice problems for you to do on the next page. You will have to jot them down. They're not in your book, they're only located in this activity here. Okay, let's get started. So in the book we've got 3 charges given, -5 nanocoulombs, -2 nanocoulombs, and a 15 nanocoulombs. Of course the 15 must be in the middle, otherwise it would be pushed away. And it tells us we have a distance of 40 centimeters. First thing you have to do is make sure you convert that to meters, so you're working with 0.4 meters. Starting with our steps. Number 1, set the forces equal to each other. So force 1, 2, force 2, 3. That's our first step. Put that back there. Got our equation here. Coulomb's constant, charge 1, charge 2, charge 3, charge 2, distance, distance. So now we have to come up with that quantity that'll help us with our distances. Of course we have distance 1, 3, and we could put our 0.4 meters minus distance 1, 3 up into this spot here. So what I'll do, moving on to, will be step 3 in our process, I'm going to take that and just substitute it right in right there and throw a squared in with it, and there we go with that. So there we are, we're through the first 3 steps already, like that. Now it's time to just take a second, make sure you have that ready before we move forward. Alright, now it's time to cancel out like terms again. Looking here, we've got Coulomb's constant, grab it please, Coulomb's constant, charge 2, and then we have our exponents again are a like term, so we can cancel those out. In addition to canceling those things in this problem, we have another like term that we can cancel out that we didn't have in the previous problem, and that is our negative sign. A couple ways you can handle that. Your math teachers would probably like you to factor out an I or something silly like that, and while that is good, sound mathematics, I just don't want to do it that way. So I'm just going to cancel out the negatives, or if you feel more comfortable multiplying both sides by -1, either way you're getting the job accomplished. So that cancels out our like terms. So now what I'm going to do is I'm going to build our equation down in the open space. So that means we have a 5, that stands for charge 1, divided by the distance 1, 3, and that of course is squared. This is equaling our charge of 2, which is charge 3. Oops, I put the square in the wrong spot, didn't I? And the distance expression there goes in the denominator with the squared attached at the end. Alright, so let's just kind of make sure that we understand why we have that there. We're not putting our charge 2 in because it's canceled out. We're not putting Coulomb's constant in because that's canceling out. So our next step is of course to cross multiply right there. Cross multiply, and let's get that written down right here. 5 expression, distance 2, and throw in an equal sign. Oops, forgot my squared. Distance squared. Alright, so we've done our cross multiplying. Now it's time for the over exaggerated square rooting. Square root everything. Now, truth be told, you can square root before you cross multiply. Doesn't matter, you'll still get the job done. So our next step is to actually do that square rooting and see what we get here. If you will remember, our 2's our squareds, not our 2's rather, our squareds cancel out, and that leaves us with this. Square root of 5, which is roughly 2.2, times the 0.4 times 0.4 minus d, and that is equal to the square root of 2 times the d. So our next step would be to distribute the 2.2 into here, into there, and that's what we get right here. Remember, if you guys need to pause because I'm going too fast, go ahead and pause. So 2.2 times 0.4 gives me 0.88 minus the 2.2 over here, 2.2 d13, and need my equal sign, equals 1.41 times d13. Now we need to add this over and steal an equal sign. So 2.2 added over gives me 3.61 d equals 0.88, and now I must divide by the 0.361, divide by 0.361, and you'll find that distance 13 is 0.24 meters. Therefore, the answer on this side, if this is 0.24, that goes right over here, it's kind of big, then this is 0.16 meters, because that would add up to our 0.4. Alright, so if you guys need to go back to any portion of that right now, it'd be a great time to do that. I'm going to give you a 10-second tick off, and then I will turn the page and show you your homework problems. Alright, so here are your 4 problems. You will be solving, finding the equilibrium position for each of the following situations. You have these 3 positive charges with a total distance of 4.2 meters. You have these 2 negatives with positive in the middle with a total distance of 5.6 meters, or I'm sorry, 0.56 meters. You got 2 positives and a negative with a grand total distance of 8.3 meters, and you've got this one here. These are all negatives, even though I didn't do this, and a distance of 0.36 meters. So if we can please pause the recording, you guys can solve it. If you guys need helping each other is good, just socializing not good, but work through these. This is of course homework, and I will be checking it on Thursday upon my return. Good luck.